All right, so in the upcoming lessons, I want to talk a little bit more about data visualization. In particular, I want to show you guys how to create some beautiful pie charts. And afterwards, I want to show you how to create a variation on the pie chart called the donut chart. Now, both of these types of charts are very, very common, especially in business reports. So it's very important that we also get these two charts under our belt. The first thing I'll do, of course, is add another markdown cell, and I'll call this number of spam messages visualized, and parentheses pie charts. There we go. Now, before we dive into the visualizations, we should probably check how many spam and how many non-spam messages there are. For this, our data frame's value counts method is going to be very, very handy. So if we take our data frame and select the category column, we can use value underscore counts and then parentheses to get a breakdown of how many messages of each category we've got. Here we can see that we've got 3,900 non-spam or ham messages, and we've got 1,896 spam messages. Now, since we're going to be using these numbers later on, let's store them in some variables. So I'll say amount underscore of underscore spam is equal to data.category.value counts, square brackets, 1, and the amount of ham is going to be equal to the same thing, except it's going to be followed by square brackets, 0. 0 because I access the first value in this series, and 1 to access the second value in this series. Now, to do our visualization, we're going to be using our old friend matplotlib. So let's import matplotlib's pyplot functionality as plt at the top of our notebook. Going to our notebook imports, we'll say import matplotlib dot pyplot as plt. Now, as usual, we're also going to be adding percent matplotlib inline. This line of code here is Jupyter Notebook specific, and it allows us to export our images for our charts when we export the notebook. So if you ever go to download notebook as notebook, then if you have this line of code in here, then you get the graphics as well. All right, so how do you create one of these friendly pie charts? The first thing I'll do is I'll create a list of our category names. So category underscore names is going to be equal to a list with the square brackets, single quotes, spam, comma, single quotes, legit mail, single quotes. And the next thing I'll do is create another list. I'm going to call this one sizes for the size of the different pieces of the pie. This is going to hold on to the amount of spam, and it's going to hold on to the amount of ham. Now we can use these two to generate our chart. plt dot pie parentheses sizes, comma, and then the labels of the chart are going to be equal to the category names. With plt.show, we can see what our basic, very, very basic pie chart is going to look like. Now, I don't recall if I actually pressed Shift-Enter a minute earlier on my notebook cell, but let me hit Shift-Enter now and we'll quickly find out. Nope. Get my name error. PLT is not defined. This means that we have to go back up, or I do at least, and hit Shift-Enter on my imports. There we go. Now I can come down here and actually generate my pie chart. And it looks like this. It's pretty ugly, actually. So we're going to have to customize this and make it look presentable. I'm going to dress it up. The first thing I'm going to do is actually make those font sizes on this thing look a bit larger. So I can access the font sizes of my labels here with the property called text props. Text props is equal to, and then curly braces, single quotes, font size, colon, say, I don't know, maybe 6. See what happens. Okay, they get even smaller. Maybe not what I want. Maybe I'll pick 16. There we go. That's a bit better. But this whole thing still very, very unconvincing. For starters, I can see that it's not very, very sharp on my screen. So what I can do in this case is manipulate the figure itself. So plt.figure, parentheses, fig size equal to, I don't know, say 2, 2, right? Changing the figure size. See what this looks like. It gets a lot smaller. But this isn't the only thing I can change on the figure size. If I wanted to make this whole thing look tack sharp on my screen, then I can actually set the density of the pixels per inch, or DPI, to whatever my monitor supports. So I've got a pretty decent monitor that I'm working with here. It has quite a high resolution, so it actually supports 227 pixels per inch. And this will have an interesting effect. So if I press Shift Enter now, you can see that the whole thing starts looking, first of all, a lot larger because it's scaled up. And second of all, the edges start looking a bit more clear. The only thing is my font size is probably a bit too large now. So if I go back to font size, say 6, then it starts looking a bit better like this. Now, when you're working on this project, have a play with the different figure sizes, the DPI values, and the font size, and see how it affects your scaling. You're probably going to have to use a bit of trial and error to get this thing looking good or looking the way you want it to on your monitor. If you ever want to export this thing and save it to put it into a report or what have you, it's probably better to create a larger version of this figure and then just right-click and save the image as a larger image. Because then if you ever need to include it into a report or into a Word document or whatever you're using, then you can downscale it and it'll look a lot better than taking a small image and scaling it up. Now, let me pull up the quick documentation on the pi functionality from Matplotlib. We can actually see that there's quite a few different parameters that we can set. Let me show you 2 of them. I want to show you the start angle, which is currently set to none, and I want to show you this auto percent parameter that we've got here and how to use it. Let's have a play with the start angle first. So if I set the start angle to 0, let's see what we have. We can see that the chart looks like so. Then we can see that this blue portion just rotated by 10 degrees from this position. And you can see this rotation actually very clearly if I start going to 20, 30, 40, 50, and so on. The blue piece starts rotating counterclockwise from the x-axis. So from a straight line that goes from the center out to here. If I set the start angle to 90, then our chart rotates by exactly 1/4 of the way around, counterclockwise. All right, so that's the start angle. Now let's have a look at the other property that I wanted to show you. Auto percent. And we're going to set that equal to, single quotes, percent sign, 1.1 f, percent sign, percent sign. And what we get now is we get a pie chart where the percent of the chart is displayed on the chart itself. The formatting is to 1 decimal point because we've put 1.1 here. If instead I had 1.2f, then it would show me 2 decimal points. So depending on the amount of precision that you want on your pie chart, you can choose the formatting of the percent sign as appropriate. Now, personally, I don't like showing too many digits after the decimal point. In most use cases, you usually want to favor readability over precision when it comes to these visualizations anyhow. If we wanted to round this to the nearest percentage, we can put a 0 here, and then we'll get 33 and 67. Now I find this chart here, size-wise and formatting-wise, is starting to look pretty decent. The only thing that I don't like are these really awful colors that it's showing me here by default. So let's change this and try to improve the design a little bit. Just so we have a record of our old chart, I'm going to copy this cell and I'm going to paste it below. Now I've got two different pie charts, and I'm going to spice up the design on this one and leave the other one as it is. One of my go-to places for picking a nice palette is a website called Flat UI Colors. Let's check out this American palette here that they've got. The first color that I'm going to grab is going to be maybe pink glamour. It means I can go back here into my Jupyter notebook and save my colors as a list. I'm going to call it custom_colors. Square brackets, single quotes, paste. This is going to be my first color, comma, back to the American palette. And now I'm going to select the color that goes well with this other category. So I think something that would be contrasty would be this blue one here. So I'm going to take this one, go back here, and add that as well. Having added my colors hex codes to a list, I can now feed them in as an argument to my pie method. So colors equals custom colors, and Shift Enter will color in my pie chart in a much more beautiful way. And I've picked some light colors so that the dark text, this 33 and 67%, is still very, very readable. Now, one thing we can also do to make the design a little bit snappier is to break out this spam section here from the legitimate email section. So we can actually have a little bit of a gap in between the two sections. And we can do this by supplying an argument here called explode. So explode is equal to, and then we also supply a list. This list will have two values, say 0 and 0.1. These numerical values here set the size of the gap. So let me press Shift Enter and show you what this would look like. So passing in an argument of 0 and 0.1 will get the chart looking like this. If we had 0.5 instead, then the gap would start looking a lot bigger. So I'm going to set this back to 0.1. And I can also meddle with the first one here. So 0.5 instead of 0. And we get, again, something like this. The offset that we're applying here, if we go to the quick documentation, essentially specifies the fraction of the radius with which to offset each wedge. Since we have two wedges, the red one and the blue one, we're supplying two numbers. So in my case, I'm offsetting one of them by 0.1. If I offset both of them by 0.1, then the gap between the two wedges doubles. Now, I quite like the look of a small offset. 0.1 will do for me. In the next lesson, I'll show you how to take these designs a little further and make a donut chart. I'll see you there.